Welcome back to the Art of Math. Today we're going to go over which is a possible answer type questions. This is going to relate to two different things, algebra and number theory. So whenever you see this thing, possible answer, not all the time, but very often, it's all about finding that magic number. So let's look at one easy question and then a harder question. So the first question will be, Bubba has only quarters and pennies, and the number of quarters is the same as the number of pennies. Which of these is a possible amount of money Bubba may have? Okay, so what we're going to do is, we don't know how many he has of each, so we're just going to say let x equals the number of quarters, let x equal the number of pennies. We're using the same variable because they happen to be the same number over here. So now the total in terms of x would be, if he has x quarters, each quarter is worth 25 cents, so that would be 0.25 times x. And from the pennies, you would add 0.01, that's 1 penny, times the number of pennies would be 0.01x. So altogether, we have 0.26x. Now, this is really important because this 0.26, that 26, is the magic number. So that means you're looking for which one of these is divisible by 26, or, how many, 0.26, but we're just going to ignore the decimal point and just treat these as 640, 676, and see which one of these is divisible by 26. And if you guys have been practicing your perfect squares, you'll hopefully remember that 26 squared is 676, so that one is divisible by 26, and none of the others are divisible. All right, so that's the idea. We found this magic number. So let's do a harder question. All right, so in this one we have, by the way, I think this originates in an SAT question. Every car is a convertible, sedan, or both. 1/5 of convertibles are sedans, and 1/3 of sedans are convertibles. What is a possible number of cars? I didn't give you guys answer choices, but we're just going to think about this question. So that's going to be the A1, the first question. And I'm going to tack on a few extra questions, which are, what are a possible number of sedans and possible numbers for convertibles? Okay, and part B is just going to flip some of these numbers around, so instead of 1/5 we'll go with 2/5. All right, so let's do part A first. There's going to be two approaches, and one will appear easier, one's a little more kind of heavy duty, so I would encourage you guys to be comfortable with both, but it's okay to favor one, if you want to use one that's a little faster. So let's start with the simplest one first. So we're just going to use a Venn diagram. Now I'm going to do a Venn diagram video probably a lot later in the series, but for now this will be more of like a basic Venn diagram. We have two circles. This is for convertibles, that's for sedans, and the center is the overlap. So 1/5 of the convertibles is the same as 1/3 of the sedans, so I've represented that here. And now I've just done C minus that to get that number, and S minus 1/3 S to get 2/3 S. All right, so here we have our breakdown. So all we're going to do is pick any one of these. Since the numbers are slightly easier on the 1/3 and 2/3, I'll pick the 1/3 and I'll call that X. So let's assume we have X in this overlap region. Well, how do we go from 1/3 to 2/3? We multiply by 2. So this is X vehicles, then this is 2X vehicles. And 1/3 of the sedans is also 1/5 of the convertibles. So now let's focus on the C's. How do you go from this 1/5 to 4/5? Well, you multiply by 4. So from X to here would be 4X. So that's how we got these three numbers. And now all you have to do is add them up to get 7X. So there we get our magic number of 7. So the only possible answers are multiples of 7. So it could be 7, 14, 21, and so forth. Now, you could ask for A2 and A3, what's a possible number for sedans? Well, since the sedan is this right circle, we just add X and 2X, get 3X, so that 3 is the magic number, so any multiple of 3 would be fine. And for the left one, we get 5X, so 5 is your magic number there. So 5, 10, 15, so forth. All right, so that's part A. Now let's see how we would do this using a slightly different method. So we're not going to introduce this X, we're just going to go off the original C's and S's. So I'm going to represent the total in terms of adding these three regions. So these two regions together just make up a whole C, plus we have that 2/3 S. So that's where I'm getting the C plus 2/3 S. Really, that C consists of two numbers, 4/5 C plus 1/5 C, but together they're just a C. Also, you could have done this in terms of S's. You could do a whole S plus 4/5 of a C. So this is not the only way to construct the total, but we'll just go with this one, like left to right. Okay, so that's your total. We have these two regions, which are your C plus the 2/3 of S. Now our job is to create some substitutions. From the original condition, we have 1/5 of C, or C over 5 is 1/3 of S, or S over 3. So we could solve either for C or S. So for C it would be C is 5S over 3, or you can go the other way, S is 3C over 5. Now it doesn't matter which one of these you use, we'll just pick one for now. So let's say we're going to replace our S. So for S over here, we're going to plug in 3C over 5. So that's exactly what I'm doing here. We have that 2/3, and for S I've replaced it. The 3's over here cancel, and we get 2C over 5 plus 1C, which is 7C over 5. Now, let's say you had gone the other way, so instead of 7C over 5, you had decided to substitute, instead of for S, you substituted for C, so we could replace this C over here with an S. So if you do that, and the 5's will cancel, and you'll get 7S over 3. So I encourage you guys to run that by yourself. So basically in this step over here, in this step, instead of replacing your S, just replace your C and add it up. So your answer is either 7C over 5 or 7S over 3. And this may look like nothing, but if we closely examine these numbers, that 7 is that same 7. That 5 is this 5, and that 3 is that 3. So what does this mean? This is saying your C better be divisible by 5, or else this is going to be a fraction. This is not going to be a whole number. So that tells us that C must be divisible by 5. That's where that came from. S better divide that 3. So S can be 3, 6, 9, whatever. If S is like 4, then you'll have 4/3. That's no good. You'll have a partial vehicle. Now, that being said, the total will be, let's say, C over 5. So that's going to simplify somehow. But then you're going to multiply by 7. So whatever this works out to be, it's going to have a factor of 7, as is this. So the moral of the story here is it doesn't matter which way you went. For the total, you'll still get that 7. So if you're trying to do part A2 versus A3, depending on that, you'll go this way or that way. All right, so that's the other way of doing it. Now let's go to part B. So you guys may think like, okay, I think I got the idea. Stay tuned, there's a little bit of a catch here. All right, so part B. So we have same setup, except instead of this being 1/5, we just have 2/5 this time. So this is 2/5, that's still 1/3, and let's run the original solution. So let's replace our 1/3 of S, we'll call that X. So 2/3 is still double 1/3, so that's 2X. But now to go from 2/5 to 3/5, from 2 to 3 is 1.5 more, so that's how you get 1.5x. If the numbers get crazier and you can't really see what the jump is, then you can always construct a ratio. So 3/5 is to 2/5, as some mystery thing is to x. So 3/5 to 2/5 is something, let's call it q, is to x, and then we'll solve for q. So if you move everything over, move the x here, simplify these fractions, you should get 3 over 2x, or 1.5x. Boom. But we don't want a 0.5 because that's a decimal. So we're going to rescale all these numbers. How do we get rid of the 1.5? By doubling everything. So that's going to become a 4, that's going to become a 2, and that's going to become a 3. Why do we do this? Because these are the first set of numbers where everything is a whole number. In other words, if I plug in x equals 1, then I would have 1.5 vehicles over here. That's no good. So that's why here I can plug in any whole number, and this is still a whole number. All right, so now we do the same thing again. We add them up to get 9x, so that all the totals are going to be multiples of 9. If we want to add up these two, we'll get our magic number of 6. Add up these two, 5x, so our magic number is 5 for part A3 for the possible numbers of convertibles. Let's try the same thing using the second approach. So again, we're going to use this middle condition and set these two equal. So 2/5 of C is 1/3 of S. And then we could solve either for C in terms of S or S in terms of C. It doesn't matter so far. So let's try it either way. So the total will again be C, which is this whole region, because 3/5 C plus 2/5 C is just a whole C, plus 2/3 S. So that's where I got this. Now, let's say we replace S with C's. So we're going to use this substitution. So we're putting in 6/5 C over here. The 3 and the 6 cancel, so you get a 2. So that's going to be 4/5 of a C plus C, so you'll get 9C over 5. So let's now try it the other way. So instead of using this one, we'll use that one. And here we're going to replace that C with 5/6 of an S. So we're going to have 5/6 S plus 2/3 S, and that's going to be 4/6. You add them, you get 9S over 6. And if you simplify that, you get 3S over 2. And that would be a mistake. So I've written here, this is super duper tricky. This had me scratching my head for a minute because remember in the previous part, we got 7 and 7 no matter how we did it. But here we got 9 one way, but then we got the 3 the other way. So that's no good because you're going to get the wrong answer if you did it this way. So let's see what happened here. What happened here is that we had two parts. Now remember, each of these parts better be a whole number. And the reason we went wrong in this simplification is that by simplifying it, you're saying, I just care that the total is a whole number. But in reality, it's not just that. Each of these better be a whole number. So if you plug in, let's say, like you can tell, this if S is like 1, you'll get a fraction here, and or let's say if you plug in S is 2, it may work out to be a whole number here, but each of these might not necessarily be a whole number. And remember, each region of your Venn diagram better be a whole number. So because we have these two parts, we cannot simplify this. Compare that to over here. So you might be wondering, like, well, how can we simplify the 6 and the 3 here? Well, this was all relating to only one of the parts. That's just the 2/3 S. That's one region. So within there you can simplify, but you can't simplify across regions. So because of that, this is really tricky, and maybe you'd want to favor that first approach. But I mean, I've been doing this, but maybe I'll switch over to this myself as well. So, but if you keep it in 9S over 6 without simplifying, then again you get the 9. So the total has to be a multiple of 9, and the number of, this is not the exact C number, but the number of convertibles has to be a multiple of 5 so that these can simplify nicely. And the S number has to be a multiple of 6. And so 9, 6, 5, these are the same numbers you're going to get from this method. So that's just so you guys are aware, anytime you get these, like what's a possible answer, there's a high likelihood they're looking for, it's like it's a number theory question where there's, think, GCF, LCM, greatest common factor, least common multiple. Since you have this 9, it's going to have 9 as a factor. So it's anytime you see these which is a possible answer questions, you're thinking like, what's that magic number that I'm looking for in the choices? And if you keep that in mind, there's a good chance you'll get it right. So again, I encourage you to think about both of these solutions. It's okay to prefer one, but I really want you guys to be able to understand both, because together you'll have more tools in your toolbox. All right, I'll see you guys in the next video.